So we do have some polls set up for you. This will help us understand what your current understanding is of the software so we can maybe structure our current and our next upcoming webinars for you according to your understanding of the software, your familiarity with the software. So I want to encourage you all to please participate in the polls. Really helps us figure out what our next webinar should be and how we should structure it more to your understanding. Yeah, I think we can start. It's time already. So good afternoon, everyone, and welcome to today's webinar on efficient steel correction design. Uh, Thank you all for taking your time to join us today. Myself, Ashwin Naga. I'm from Acero Consulting Engineers, and I'm senior sales manager here. I handle all the commercial business. So we are all delighted to have you all join us today. In today's session, we will explore how IDEA StatiCa helps you design all your structural steel connections, no matter their geometry, in minutes. The goal of this webinar is to give you a practical overview of how the software simplifies connection design and helps teams save valuable engineering time. So with that, let us begin the session. Let me quickly walk you through today's webinar. So we will begin with the introduction of IDEA Statica version 26 and its key enhancement. It's the latest version that just rolled out. We will move on to the connection design and prediction workflows, followed by its advanced analysis capabilities, including stress, strain, and code checks. We will also cover cost estimation of steel connections along with licensing and support. And finally, we will wrap up with the question and answer session. By the end of the session, we hope that you will have a clear understanding of IDEA Statica and how it fits into your connection design workflows. We will cover its core capabilities so you can efficiently handle steel connection design and analysis. You will also gain some insight into the best practices to improve accuracy and deliver reliable results in your projects. Finally, we will share some useful resource materials, including documentations and tutorials to help you get started smoothly. So before we begin, I'd like to introduce you to today's presenter. He's Mr. Kirti Chandra Joshi. He's the structure engineer here at Acero. Kirti holds a MTech in structures from Delhi Technological University. He has hands-on experience across IDEA Statica, RISA, Adapt, Bluebeam, RFEM, and more. He'll be taking you through today's detailed technical walkthrough in just a bit. Before we dive into the product, a quick overview and a few words about who we are here at Acero Consulting Engineers. So, other than providing and reselling these softwares, we have proud to have worked with more than 300 clients, delivered more than 30 products, and supported projects over 20 plus locations. Our team is made up of postgraduates from top structural engineering universities. We help our clients improve your productivity, streamline your workflows, and get the most economical possible solution. Uh, we do that through regular knowledge posters, webinars, and resources, and we ensure that you keep learning and extracting more from your tools, your softwares, as we move along in our partnership. Right. Coming to the products and solutions that we sell here at Acero. So we are channel partners of multiple AEC softwares, one of which we will be focusing on is IDEA Statica, right? It's for advanced steel connection and design. Autodesk, we also sell. It's one of these softwares I think all of you might be familiar with. We also have Karamba, Shuriken, Adobe, and Aries. If you want to know about any of these softwares, you can connect with me, you can connect with Acero, and we'll help you uh, figure out and understand if these softwares fit into your workflows. So along with these, we also offer these softwares under our Nimishek portfolio. So we have Bluebeam, which is a smart PDF collaboration for AEC professionals. So basically a PDF which works for all the AEC professional, help do markups, quantity takeoffs, and many other things. We also have RISA, which is uh, which is Arisa 3D floor and connection, which is for integrated modeling, connection, and design. For post tension and reinforced concrete, we have Adapt Builder and Adapt PTRC. Uh, for a BIM-based design platform for architects and engineers, we also have Allplan, right? Yes, all of these softwares we sell here at Acero and we provide support for it. We do regular webinars for it. So if you are interested in any of these, please do feel free to reach out to us. You can connect up with us after the call, or you can connect me with your technical team or your IT team or your purchase team to help move things along, right? So with that quick overview, let's quickly dive into the IDEA Statica software itself. I will hand over to Kirti. So Kirti will take you through the software's core features and the live overview. So yeah, Kirti, your screen is visible. You are audible.
Yeah,
Please
yeah.
move ahead.
Hi. Thank you, Ashwin. I hope like I'm audible, right?
Yeah, clearly audible. Yes.
Yeah. Hi, good afternoon, everyone. So to start with, IDEA Statica is a software you might be familiar. That is for designing either the simpler or the complex connections. For example, it may be beam to beam or beam to column, or it may be the bracing or the base plate connections. So it performs all the code sec using the CBFM analysis. So that, definitely help us to understand the behavior of the connections, including the bolt, weld, or the plates. And the software has a large database of predefined 2D and the 3D connections. And this helps you, save a lot of time. And we can directly use these templates and modify them instead of scratching it from the scratch. So it covers all common connections like such as the shear moment, either base plate, the splice, or the bracing connections. So as you can see on the graph, so according to the steel construction cost joint publication, and from the Tata Steel, the combined cost of a fabrication and the raw material is about like the 60 to 80% of the end product. Implementing IDEA Statica for steel connection design will definitely help in reducing the number of the over design structural steel connections, and it helps to reduce the excess steel uses and also the carbon consumption during the fabrication. So moving forward, besides the connection design, IDEA Statica also includes the member application, which is a part of the IDEA Statica itself that is used to design and verify the members, such as the beam, it may be the frames or the CFS section, or it may be a transverse beam or the bridge diaphragm. And what it does in the member analysis is it performs the advanced analysis that includes the materially linear and like the non-linear, and the geometrically and the materially non-linear analysis. We call it as the GMNIA. And it also includes the linear buckling analysis to evaluate your member stability and the buckling behavior. So as you can see in the concrete part, you can analyze and design the concrete D-region, such as that may be corbels or the deep beams, or even the wall elements within the IDEA Statica detail. So IDEA Statica concrete supports all of your steel connections, as well as the like IDEA Statica support your steel as well as the concrete connections. Like you can combine both the IDEA Statica steel and the concrete. For example, while designing a base plate, you can design base plate in IDEA Statica connection, and then you can design your reinforcement in IDEA Statica detail. So that may be the workflow that may be looking worth into. So coming to the next slide. So the latest version of the IDEA Statica is the version 26 that is released last week only on the 22nd of the April this month only. So it comes with the several new features to make the connection design faster and more efficient. So one of the key addition is, as you can see on the graph, is the AI powered predictions of the connection utilization. It used the machine learning, and that allows the engineers like us to instantly evaluate a connection utilization for the governing load case even before you run a full analysis. Like you can see, I have highlighted it into the red box. You can see it automatically predict your connection utilization. And there is also support for casting plate design. It's for the AISC or the ACI code if you're working with American code. So it includes the reinforcement and the headed stud, or it may be the both. So regarding the beam and the checkboard, there have been further improved for better integration and the data exchange when you typically work with a large or the complex model. So basically, with this updated version, it reduced the memory uses in your system in for your 100, for example, 1,000 plus nodes of project you might have, and it ensures smooth interaction without any lag or the crashes. Also, as you can see, the user portal for this has been enhanced. You can easily track your user activities and the license management. You can now see the last active timestamp for each of your user in the license, and you can easily identify the most active and the inactive users and optimize your license utilizations with these updated versions. So in addition to this, it also includes the concrete design. It's for the Arthro design code, which may be useful if you're working with the infrastructure of the bridge project. So along with this, there are several other improvements. So you can, definitely check this all the details from the IDEA StatiCa website. So as you can see, it has a user-friendly interface. The interface is shown here. So you can create any connection typology in just the few clicks, and to modify the design, it has some real-life manufacturing operations as seen in the slide. The manufacturing operation, I mean here, all the components that are used in the connection. For example, it may be the fin plate, the in plate, or the stiffener, or the splice, or even the gusset plate for bracing, and so on. Yeah. So with IDEA Statica, we can definitely model all these connections in 3D and see how the forces are flowing through each of the component. So with the IDEA Sterica, we can design all types of the steel connection, no matter how simple or complex the geometry is, in just a few minutes. And the important is the software makes connection design fast by that provides more than 10,000 predefined configurations along with the parametric templates that we can save and reuse as our company standards. So instead of starting everything from the scratch every time, we can directly use the templates and modify connections as needed. So it also supports the connection library with 1 million plus ready-made steel connections from real life projects from all around the world. Uh, so next is it also handles everything from simple to very complex connections like we discussed, and we get all the advanced along with all the detail and the exportable report that may be include all of your limit step port check, and it handles any geometry or any type of the loading, whether it is moment, shear, the axial or the seismic connection. And most importantly, at the last, you can see it helps us to avoid the oversized connection. So by checking the joint early in the design stage and trying out the different options, we can optimize the material usage and reduce the unnecessary steel, and it can ultimately save the cost and what the carbon. So yeah, like I mentioned, it support multiple connections that may be from the simple to the complex, or gusset plate, or the brace stiffness, or the heavy column anchoring footing system, as you can see on the slide. So these are few of the example forms, hundreds and thousands of other which you can create within the software. So you can take any template and keep editing it, and you can achieve any typology in just a minute. And you can carry it out very it may be used for your wide range of project also, which maybe includes the your complex joints such as the project from your industrial structure or from the bridge, or it may be from your like the power plant, or it may be from your tower structure. So yeah, actually, it I mean to say is you can easily model these connections accurately and verify them according to the design code. So coming to the next slide. So as we know that designing the safe connection is obviously important. So, but cost, also plays a great role, specifically from a fabrication point of view. So with the IDEA StatiCa, as you can see on the slide, we can estimate the final price of the created design. That will definitely look into the demonstration part also, and we can optimize the design. So price of an individual connection component can be specified within these settings on a cost per unit weight basis. Uh, and it calculates the cost, based on the key components like a steel plate, as you can see, the weld, the bolts, and even the hole drilling. That may be as a percentage of your bolt assembly cost. And we can modify the connections using the different manufacturing operations, and the cost automatically update instantly. So that means like we are not just designing just for the, safety, but we are also optimizing for the cost. So even small changes in a bolt or the weld size or even the plate thickness can impact the overall cost. So we will definitely check this into the demonstration part. So coming to the next slide, so it performs the code check according to the 8 major international standards, such as the Eurocode, AIS, Canadian, and other global standards. So for the Indian project, it supports the IS 800 2007 for the steel design, and again, for the like the Indian project, if you are using the IDEA StatiCa CBFM analysis approach, so you can evaluate the plate deformation, the joint stiffness, that will also cover today, and also the weld stress distribution just within a IS 800 workflow. And it also helps you to validate whether your connections is pinned or the semi-rigid or your rigid connections. So like these are the types of the analysis you can carry it out in IDEA StatiCa analysis. So it performs the stress strain analysis by default, where the strain check of the plates with the code check of the components are basically performed by the elastic plastic analysis. So next is the buckling analysis that calculates the buckling factor or to verify like if the plates or the point like the parts of the joint are too slender. And stiffness analysis you can see is to determine whether the connection behave as a pinned, semi-rigid or the rigid. So also you can see the capacity design. So this is important for the seismic structure, to ensure that the plastic hinges are formed in the intended locations. So the joint resistant design, as you can see, will give you the design capacity of the connections that may be as a percentage of a applied load. And it may be great also for checking your existing connections. So today we'll see the stress strength analysis and the stiffness analysis in today's webinar. And the more detail about the stiffness analysis, like it provides the moment rotational, like the rotation curve as you can see here, and it calculates the rotational stiffness of a connections and classify it as the either semi-rigid, rigid, or the pin connections that may be further integrated into your global structural model. So this is regarding like how we can import your connections from any of your FES software to the IDEA StatiCa. So if you are already using the IDEA StatiCa, many of you might be already aware of these features that these checkboard features will automatically generate the internal force for your joint from the global analysis software after exporting it into the IDEA StatiCa. So now for importing joint, so you just have to select the joint, and there is a plugin so that will automatically import, like imports the connection into the IDEA StatiCa, and you can adjust the load and start designing. And the output will obviously gives you the overall code set. So it can be integrated with the FVA or your CAD programs like the ETAP, SAP, or the Tekla structure, or it may be the Autodesk Revit. Basically, with the FEA programs, the geometry, the profile sections, and even the load cases are automatically exported. And from the CAD programs, the profile, the plate, bolts, and the welds are also automatically exported. So here you can see like how the connection design carried out in IDEA StatiCa has different advantage over the manual connection design. Like in manual design, we spend a lot of time doing the hand calculations using the spreadsheet and checking out the component one by one. So that is obviously the slow and the repetitive work. So specifically when we are have the multiple similar connections in a project. So to avoid this, like with the IDEA Statica, the process become much faster and consistent. Like it automates the design that uses the CBFM analysis and gives the port check result. So we'll also get a full 3D visualization of the stress and the force, and instead of just the 2D sketches. So the port sets are also automatic. So it's obviously saves a lot of time and reduce the error. So I have one example here, like in the example on the right, you can see that the manually designed the SSS column splice is heavier, like while the same connection design that Aesthetica is more optimized. This means the less steel and obviously the lower cost and the less carbon consumption during the fabrication. So you can save both the tonnage and the cost on more number of connections and get a strong return on investment. So yeah, in short, like it helps us to design faster and optimize better and definitely save a lot of time and the material cost. So one of the case story mentioned in the IDEA Statica website, which is quite interesting, is on the connection optimization using the IDEA Statica from the Voltman Steel Group, like which is one of the leading fabricators and production of the steel structure. So implementation of IDEA Statica connections to their workflow basically decrease the uh, consumption and handling of the materials and the welding cost compared to their previously used approach. For example, as shown in the slide, you can see the standard connection that was compared with the same connection designed using the IDEA Statica. So by applying the CBFM method, they were able to optimize the different components like the in plate or the stiffness, the weld, and the bolt. As you can see on the slide, the in plate thickness was reduced from 25 mm to the 20 mm, and uh, sorry, the number of the stiffness also came down from 4 to 2, and weld size are also minimized, and even the bolt arrangement was optimized. So because of these changes, they achieved the significant saving, like around 25% in the plate, so 60% in the stiffness, and 70% reduction in the welding volume. Is the welding volume determines the welding cost, and about the 33% reduction in the bolt. So I just wanted to highlight this example to show how like connection optimization can directly impact the cost and fabrication when using the IDEA Statica. So for more detail, you can read out all the articles published in the IDEA Statica website. So I have, so we'll go into the software part. So I have created a small video, so where we will see the stress strain analysis, and we'll also check out how we can carry out the stiffness analysis in the IDEA Statica, and definitely we'll also see the cost estimations and the optimization. So this is the latest release of the IDEA Statica version 26. That has been released last week only. and you can see all the updates and all the highlights are already mentioned while you open the IDEA StatiCa applications, and there is the release notes mentioned in the IDEA StatiCa, so you can definitely go to that from your desktop application also. So I will quickly open what all things are mentioned in the released application. So I try to cover the important point in the slide itself. So it has some implementation regarding to the steel, concrete, and the beam workflows. So moving on to it has like the steel and the concrete. We can carry out the steel concrete project, but today we'll focus on the connection design. So we'll click on the connection, and it will open our connections template. Now you can see there are different types of the templates already available. For example, you can select the geometry and you can select the design. For example, for the base plate are there are the beam column connections. So multiple types of connections templates are already available. So you can pick out one. And for example, if I want to carry it out for the beam column connections, and I may be simply clicking on any of the templates. So the important things to check here in this updated versions is you can see once you click on any of the connections, there is the symbols below in all of the connections. So these symbols are different. So the second symbol which I have clicked right now is the symbol for the parametric template. So that will design and include all the parameters that is mentioned when you click on this icon. And the first options, as you can see, once you click on the particular connection, it will display the connection name right now. And in the first option right now, I can click on the icons, and this you can see the predicted utilization. So this has been updated in this latest version only. So once you click on this, so predicted utilization is available only for right now for some types of the templates, and in the upcoming version release, it will be added in for the template as well. So once you click on any of the template, you can check out and determines the connection frictions, and also the more lot of more of features that is included in the latest versions is you can select the AISC code, and it is great for if you're working with the US project. It will gives you the templates based on the AISC code as well, like as you can see on the screen. So I'm going back to the first options, and just for the demonstration purpose, I will just click on one connections and the fin plate connections, and I will just click on create selected design. And I will just wanted to show you like how it like in the upcoming, like in the latest versions, it has been updated. Like now you can see on the screen at the top, you can see the production cost has been like you can see the predicted utilization is 39%. So this is the features I'm talking about that is updated in this latest versions. So once you click on any of the parameter from the template that is shown on the right hand side, the utilization will automatically change it. So before running your analysis, you will be getting your you will getting the connections utilizations prediction that is through the machine learning implemented in the IDEA StatiCa. As you can see, for example, if I want to change any of the parameter, for example, bolt column, so from column 2 to 1, it has updated my predicted utilization even before running the analysis. So you can definitely try out these features. It is a lot more interesting feature that has been updated in the recent version. So coming to the next part, now we'll perform some of the analysis, this resistance analysis and this analysis. So again, I go back to my template, and I will select one of the template directly from this connection template. So right now I am going with the in-plate connection template, and I can simply click on create the selected design. And the template has been assigned, so you will get to see like all the members, the load applications, and the operation that are used for these connections to the template. So the template features is available. So you can change any of the parameter, for example, the rows of the bolt, or if you want to hide also the stiffness, you can definitely change out this from your the templates. and that is available as you can see on the screen. So as you can see, like if I want to, rotate, you can easily rotate it. And if I want to change the number of rows, you can see I have changed it from 5 to 4 number of rows, and it has been updated easily with this template. And you can explore this template as well. As you can see, the explore features available at the totally right hand side. So, for example, you can see under the operation, there is a template, and under the template, there are two operations. That is the EP1, which is the in plate, and the stiff one, which is the stiffness. So, this template is the parametric template. So, you can either work on the template, and you can even work on your operation individually. But if you want to work on the individual operation, work on the in plate, for example, you need to explode this template first. Without exploring the template, you are not able to edit in the inputs. So as you can see, we can easily change the the plate thickness or the parameters that are shown using the templates, and it will automatically update. Right now, I'm just keeping it as the same, but you can definitely try it out. And if you want to show and hide the stiffness, you can just select it from the template itself. And right now I can see I'm not able to edit my EP1 and the stiff one. But if I click on explore the template just by right clicking it, or from the operations, there is the options to explore all templates. So if I click on that, then we will be able to edit the parameters from our in plate and the stiffness. Right now you can see. And if I click on the input, so it will display the property related to it in the setting, like the EP1 project parameters. So you have the different options. So you can, display your member labels from the design setting at the top. So there is the options of the members. If you click on that, then it will show and hide your member. Yeah. So as you can see on the in-plate one, there are the different options like the member one, member two, and I have already assigned the tips now like the in-plate one on member B, member C, which is the column, and that is attached to the beam's top flange in both the side. So you can easily change the thickness and all the parameters, and you can even welded your in-plate directly. So there is the options of welded and the bolted. And you can see the top and the left and the bottom dimensions option are there. So you can easily, if you want to increase the plate dimensions from left to right and top to bottom, you can easily use these features. As you can see, so you can easily gives out the different dimensions just to change out your plate dimensions. So there is the option of the backing plate, as you can see below. So once you click, right now there is no backing plate, so once you click on that option, so it will apply the plate on this column flange. So backside of the column flange, you can see now the plate has been added using that options. And regarding the bolt, you can easily set out your categories like the bolt size and the bolt grade, and you can easily change the bolt dimension. For example, I am modifying it easily with the tops and the left layer options, as you can see. So you can just change its dimensions just to for a bolt arrangement. So right now I'm just keeping it as edit as it is. And in the weld option at the top, right now it is the double fillet weld. and you can change the well thickness also. And the next one is the stiffness plate. Right now, I have only the two operations. So in the stiffness, once you click on the stiffness, then you will see the property related to it. Right now, stiffness has been added on my column. So on members fee, which is the column, as you can see on the label, column label, and stiffness is related to the B, which is the beams. So right now you can see both the stiffness are added. So I have used the both options. So if you want to change the orientation of the stiffness, you can just click on lower, upper, and the center. Right now it has been added related to the beams top and the bottom flange. And you can place your stiffness in the rear side of the front side of your column. So from the top view, as you can see, you can easily change this orientation also. You can also change the width of this stiffness, but by default, it is set at 0. 0 means it is defined, it is occupied as per the cross sections of the column size. So if you can want to change it, you can definitely give out the dimensions. Right now, I have just given it as 100 mm. And you can just use the dimensions option just to take out the dimension. Right now, you can, I am just measuring it. As you can see, it is showing me at the 100 mm. So at a width. You can also show it in the isometric view. You can just rotate it using this XYZ icons. The next one is the inclination. As you can see, if you want to orient your stiffness with an angle, so you can definitely do that as well in the IDEA StatiCa. So right now I'm just keeping it as the horizontal. And if you want to use the chamfer corner, you can use, you can provide the chamfer. Basically, in the, there might be the rounding. So it's, you can provide the chamfer. So this options is also available. So this is related to the operations stiffness and the inlet. And right now you can see my column is there, beam is there with the stiffness and the inlet connection. So we'll just check out the load. Right now in the load feature, you will see at the top, there are two options, the loads in equilibrium. So once you click these options, then it will calculate the unbalanced force. That is the sum of the verticals. That is the sum of the equilibrium. The loads in the equilibrium must be the 0. So I'm using this load in equilibrium features. But if you don't want to use this loads in equilibrium features, then these continuous members will be supported in both the directions, and you will be only able to provide the load in this beam member only. That is the fixed member. So right now you can see. So it's I use the load in equilibrium feature right now so that you can apply the loads at both the ends. So I just run the analysis. So by default, the analysis is the stress strain analysis, and you can see the analysis. The basics analysis has been performed. So the plates are 0.3. That is the limit is the 5% strain, and the bolts and the weld utilizations are also displayed. Right now, the buckling is not calculated. So we are also calculating the buckling, and it is giving me the factors for the buckling also. And if you want to check out your results, you can definitely check out the stress and the equivalent strain and the deformed shapes for your connections. So right now you can see it looks okay to me. So also you can go through the deformed shape as well. And there is the options of the bolt for, so you can definitely try just to use all of these features. So it will calculate all of your plates, welds, and the bolts. So under the bolts also, it will give you the limit state port check for all of your equations, as you can see on the screen. It will give you the as per which of the clause from which of the codes it has calculated. So you will get all the details equations, and also for the buckling, as we have calculated, you will get the buckling factors. and you can display the buckling shape also for each of your shape. So right now, you can just carry it out this stress strain analysis that is by default. So you can also generate your report once you are done satisfactory with your results. And if you want to change out your material property anytime, you can do from the material tab at the last, you can see. So you can change out the property related to your material and the cross section from this tab. And under the report option, I'm going and I'm just generating the detailed report for my connections. Now you can see the report has been generated. You can further export it into the PDF as well. And as you can see on the right hand side, there is the general and the project settings, like the settings options. You can uh, add whatever you want to include and whatever you want to exclude in the report from the settings. For example, right now you can see there is the formula and the explanation options in the general tab. So if I want to include that in the report, I can just simply click on the formula and the explanation options. Right now it is off. So I'm just clicking it and I'm just generating my report right now. If you scroll down, you will get all the equations and all the explanations and the formula used for calculation in the report itself. So you have the options to customize your report and you have the options to export it into the DXF or the PDF. So next we will see is we'll save this model first and we'll perform the stiffness analysis. So I'm just saving it as the moment connection and giving it as my name. I can save it in my desktop folder. And yeah, so right now in the member option, so I just wanted to highlight this also. So there are the members property also. So if you want to change the cross section for your member, you can definitely click on the members and the property related to will be visible, and you can click on the cross sectional property. There is the plus icons and you can insert the new cross sections for your hot rolled, the composite, the build up sections are also there. So you can take out these sections. So I'm taking the hot roll sections, and you can define a custom section also, or you can use the library also just to include it in your cross section database. So you can select any of the sections. Right now, I'm just showing it as a Eurocode. So all the Eurocode sections are available, but the Indian sections are also available. So next is we carried out the stiffness analysis. So basically the steps for the stiffness analysis I followed is carried out the stress strain analysis first to ensure that our modeling is correct. Then what I will do is I will just copy my connection and change its analysis type to the stiffness. So in the right and left hand side, you can see I can just copy my connections. I copied my connections, and in the setting tab, I will just change it to the stiffness. So the different types of the analysis you can carry it out. Once it change it to the analysis type, right now you can see I have my members properties that will be related to the stiffness, and we in the stiffness analysis we just need to select one member. We need to select the analyzed member, and we need to give the stiffness length. As you can see, if you click on any of the member, there is the theoretical length options in the stiffness analysis. So that can be compared to the buckling length. That is basically the distance between the support. That is for the purpose of the bending of the element. So you can provide this stiffness value also, and you need to select your analyzed member. So by right now, my beam is the analyzed member because you wants to what it does it calculates the rotational stiffness for only one member. You want to, for example, you want to access the stiffness of beam to the column. So if multiple members are there in the connections, right now in our case there is only the one member. So if there are multiple members, then the other members are considered as fixed. So at a one time it will analyze for one member. Basically, it's the incremental and the iterative process. So only one member is analyzed. So you can set out the buckling length, and in the load case, you can define your load. The next is once you provide the stiffness length and the select the analyzed member, then you can input your moment value. Right now, by default, there is the shear force and the moment. So I'm just creating the two different load case, copying the load case, and in that case, I'm just assuming the moment only. So there are two cases so that I will run for this. So once we can also rename this load case just by simply clicking on the right click. So it is V, so it will be my yum. So I'll just edit it again. There are two load cases right now, so I'm just giving it as a symbol yum. So there is moment and here, and one is the moment. So I will just click on calculate. So as I mentioned, it is an incremental, like it is an iterative process. So it once it is the analysis is done, it calculates the rotational stiffness around the local y axis and the z axis, and we get the moment rotation curve like now you can see on the screen. And it has classified its the class also. So you can see from the here also you will get a table and the moment rotation curve. Also, if you click on the report tab, you can get uh, this information from the report tab also. So I'm just going on the report and just click on the formulas of the, for example, I'm just generating my detailed report, and I'm scrolling it down, and you can see there is the stiffness analysis. There is the two cause that is for, because there are because I assigned the two different load case, one for the shear and the moment and one for the moment only. So you have, like I have get the two different cause, and I've also get a rotational stiffness table also. Yes. So there are all the parameters, like there are all the nomenclature given for these symbols that are used in the symbols explanation. So basically, there is the symbol, for example, as you can see, MJRD, which is the bending resistance, and the SJ, which is SI, which is the initial rotational stiffness. So all the nomenclature are given, and uh, you will get all the tables. So for example, the initial stiffness value, it is calculated where the behavior of a connection is still linear, as you can see on this graph. From here to here, it is quite linear, and it is estimated using two-thirds of our bending resistance, which is MJRD, and we draw the straight line, and based on the value, that will be our the initial stiffness. So it will calculate the initial stiffness as well as the second stiffness. A second stiffness can be calculated as the intersection of the input design moment that were provided. So here you can see that MZRD, that is basically the design resistance, which means the capacity of the connections. And at the last, you can see, and the table also, you can see the phi value. So the phi values are the rotational deformations of the given moment. And yes, J limit values is there for RNP, as you can see, that is the yes is the limiting resistance for your rigid and the pinned connection. So for example, there is, if this value, if the initial stiffness, if the stiffness initial stiffness value is less than like it's more than this SJR, which is the limiting resistance for the rigid connection, then our connection will be assumed as rigid. And if the value falls below this SJP, which is the limiting resistance for the pin, then our connection will be classified as the pin connection. If the stiffness values falls between these two values, then it will be classified as the partially restrained, which is the semi-rigid connection. So as you can see, our stiffness is the initial stiffness is 17.5 meganewton millimeter per radian. So it is falls under the 202 and 4. So it is classified each as the partially restrained connections. So I have another example just to showcase. So I'm just giving a full welded just for the demonstration purpose and wanted to see how this gives me the connection classifications. So once I run the analysis and I'm not interested in detailing right now. I'm just wanted to interested in checking out the stiffness, like the classification of the design. So yeah, you can see right now our stiffness, initial stiffness values falls between this limiting resistance for the rigid and the pin connection. So our classic, like it exceeds our limiting resistance value for the rigid connection. So our classification for the joint is classified as the fully rigid connections. So this stiffness analysis result can be used as a feedback to a global model, just to further increase your accuracy. Like you can, once you import a model from a SAP or this CAD, you can calculate the stiffness for your connections, and then into your global model, you can put out the stiffness values and run your analysis, because normally we treated it as the rigid and the pin connections. And once you provide the stiffness value, that is for the semi-rigid, for example, then you will get a different bending moment diagram, and it will give you the realistic behavior for your global model as well. So that can be used as a feedback to your global model to increase the accuracy. So this is regarding the stiffness analysis. So how you can classify our joint using by carrying out the stiffness analysis in the IDEA StatiCa. So the next is the short video on the cost estimations. So I have the similar connection, the same connections open here. So basically what we'll do is we'll set out different types, different cost for it, and we'll calculate the cost estimation. So in the project setting options, as you see on the screen, there is the cost options. And once you click on the user preference and the cost default, you will be able to provide your input. And there is the options of currency symbols. So right now it is showing me as Eurocode because I have opened the Eurocode by default. If you open it by the IS code, then there will be the rupee symbol. But obviously you can change out the symbols from euro to the rupee. So I'm just copying my symbols. And if you click on calculate the cost and save it as a default, so next time you open a connection, the cost will automatically show in your window. And the next below, you will see the cost default options where you will fill out the cost for the different parts as per the steel grades available. So once you click on it, you will see the material for the steel grade, and you can set out the cost as per the materials. Right now, I'm just giving values just for the demonstration purpose. For the fillet weld also and for the CGP weld, you can just give out your the cost per unit kg. And for the bolt assembly also, you can set out your cost for your bolt grade. For example, I will try to add two different category of the bolt for M8.8 and M6.10, and I will set out a different rate for this bolt per kg. And you will, and it will help us to predict the cost estimations once our connection is done. For example, there might be different categories of the bolts in our connection. So you can set out the cost is for the bolt grade also. For all of the other connection, I'm giving values of 200 per kg, as you can see, and hole drilling also right now 30% is fine. So it is a percentage of the bolt assembly price basically. So 0.3 is fine. So you can set out this different cost even for the fabrication also. And once you save, yes, once you save as a default, next time you open, it will automatically show the cost. So right now you can see the production cost has been displayed in my screen because we have set out the different unit price per kg for these different parts. And based on the weight of the steels used in this connection, it will calculate me the cost. So I'm just running my analysis here just to check whether my connections is okay or not. So right now it is showing me okay. And I can just go on the report tab and generate the cost estimation. So in order to, display the cost estimation, so you just need to click on the cost estimation because by default it is being hide sometimes. So if you click on the cost estimation, it will include the cost estimation in your report. So there is the options of bill of material also that may be used. You can export the connections from bill of material to the DXF further. So there you can also include that in the report as well. So I'm just clicking the bill of material in the cost estimation and just generating the report. So as you can see, I am getting the sections and all the informations as you can see. So I'm right now interested in the cost estimation part. So as you can see, it has calculated me the cost of the steel, total weight of the steels and unit cost which we have provided and calculated me the cost. Similarly for the bolts and the weld also, whatever the input we have provided to the setting, it has calculated as for the weight used in our connection. So we can definitely check and optimize our connections. And we can also see you will get a cost summary also. Is what is the total cost of my connections, and below that you will get a bill of material. So you can also generate the BOM directly. You can one page BOM also you can generate instead of the full detailed report. So I'm simply clicking on BOM options, and once you click on BOM, then you will generate the bill of materials. So as you can see, you will get all the informations, and it can be further exported to DXF uh, also. So if you can see right now the production cost is displayed here like 3367 rupees for these connections, and you can select any of this connection, and you can I will try to change the any of the parameters, and it will automatically change the production cost based on the quantity of the steel used. So there is the options of the auto design feature as well. Like once you click on the operation, and it will auto design all of your connections. Just in one click, you will have the options of auto design. So basically, IDEA StatiCa connection, it is used basically for the weld sizing. As you can see below the auto design, there is some options. So this is to check if there are any missing weld in our connections or not. So it will easily identify. Right now, there are no missing weld in my connection. So I'm just right clicking it, and you will see all the options. You can automate the weld size based on the different categories. You can see by default. Basically, there are two full strength weld sizing are available to all users for full strength and the over strength. But for the Euro code, there are two more options. As you can see, the capacity estimation and the minimum ductility. So if you click on the Indian code only, so you will see no option for the estimation and minimum ductility. So you will see only the options for weld strength, full strength, and the over strength. So full distance, as you might aware, it calculates the full distance and provides the weld that is stronger than the plate. And with the over strength, that will automatically provide the weld that are much stronger than the connection plate. And this over strength factor can be specified in the setting that we'll see. And the default value of 1.4, I think, it's taken from the Eurocode to form a plastic hinge, I think. So for the user code, there are, like I mentioned, there are the two more options. As you can see, the capacity estimation and the minimum ductility. So the capacity estimation is like to calculate the capacity automatically provides the weld size. Basically, data is strong, just enough to transfer the set of load. And to the minimum ductility, so weld sizing are automatically provides that are stronger enough, to prevent the bit like the brittle failure. So you have the options to auto design as well. So you can click on any of the options to optimize the design. Right now, I click on any one of the options, and it has given me the production cost has been displayed accordingly. For example, if you want to reduce the stiffness, it has reduced my production cost overall. So once you reduce the thickness from 16 to the 14 also, it will reduce my production cost of displays in the screen. And at the design option, there is the option for the weld that will automatically design your weld sizing in your overall model. Once you click on that options, it will also fix out your weld. So right now you can also see the production of cost has been reduced by providing the auto weld sizing through the IDEA StatiCa. So the weld sizing, automatic weld sizing is the first machine learning feature that has been implemented in the IDEA StatiCa, like the features that is used for the automatic connection predictions. So right now, for example, my stiffness has the flange weld of 4 and the web weld of 4 mm. If Let me check if I can even optimize this. So I can simply click on the operation, and by right click, you will see the options of the auto design. And once you click on auto design, then it will give you the welds and the flange. So right now you can see the 3 mm is also okay for this connection type, as you can see, and the production cost has been displayed accordingly. So also for the plate, for this in plate, you can define it as the extended in plate or the flush plate or the shear plate as well. So once you click on any of these options, right now this is the extended in plate. So next is the flush plate I'm using, and the next one is the shear tab only. So based on this plate also, the production cost has been increased or decreased based on the the weight of the steel used. So by changing any of the parameters, it is easily visualized to see the difference in the production cost. If, for example, if you change the weld size from higher to the lower limit, so you will get all the information uh, in the IDEA Statica graphic, like the window, the production cost, and also through the reported you will get. So in the setting, there are further setting you can definitely adjust for the analysis and for the check also. So the limit plastic strain is set out as 5%. So based on these settings, the software checks our strain in the plate. So you can change all of this. So in the model, you can provide the mesh size and the number of the iterations, analysis iterations, and everything. And in the design tab under the general, you will see the options for the over strength factors that is used for the auto design of the weld. So you can set out these factors in these settings, project settings, and you can carry it out the auto design. You can select out the auto design features in the IDEA Statica and optimize your connection design. So it can integrate with the analysis and the BIM software, like I mentioned, for the FEA program, it is integrated with the different programs as highlighted in this slide. It may be the ETAF, the SAP 2000, the STAT, so the TechLight Structural Designer, it may be a MIDAS. So for the CAD program, it is related, it may be integrated with the TechLight Structure, the Autodesk Revit. So basically the geometry, the profile, also are automatically exported when you link your FEA or the CAD programs to the IDEA Statica. So one of the case study I've highlighted. So you can also you can also explore a lot more of case study on the IDEA Statica from their official website. And you can also see, like IDEA Statica says the video success story on the YouTube, where you can hear directly from the engineers about their experience using the IDEA Statica. So I've added the snaps of the IDEA Statica story and the case studies, and you can just go through these links and you can just have a look at it. So to summarize today, what we have covered, we have covered an overview of the IDEA Statica version 26 that has been recently launched. And we looked at how to model our connections using the parametric templates and predict the connection utilizations. And we have also covered the analysis features like the stiffness and the stress strain analysis. And we also checked like how IDEA Statica helps in the cost estimation, like how we can set out the cost for our steel connections and how we can generate the bill of materials, which is useful from a fabrication point of view. So we also touched on some of the case studies, and we'll informed at the end of this webinar regarding the licensing and the support resources. So yeah, I hope this session was helpful to all of you who have attended. And in the coming webinars, we'll go deeper into the specific topic and explore the advanced connection design step by step. So we'll display some poll question here, and then we'll take out your few questions.
So again, thank you, Kitty, for that wonderful presentation, and I hope everyone else found it insightful as well. Again, your engagement with these polls helps us understand and customize the upcoming webinars to your liking. So we very much appreciate all your responses. So moving ahead, we would like to ask if you have any other questions, any questions regarding IDEA Statica and whatever is was being presented today. You can post it in the Q&A chat box that is present on the top taskbar, and we would be more than happy to answer all your questions right here and now. And if you don't have any questions, I can probably move ahead with the frequently asked questions that we do get from our Idea Statica customers. Uh, so one of the questions that we mainly get is how are the bolts how the bolts are modeled in moment connection designed. If the bolts are modeled as a spring, then what is the stiffness values it considers for analysis?
Yeah, thank you, Ashwin, for the question. So this is the questions we received in the last webinars, and we try to, due to the time limit, we are unable to try. But yes, I am bolts are modeled as the non-linear springs within the IDEA Statica. So regarding the stiffness value, so stiffness is not the user defined, and it is automatically calculated, based on the bolt diameters, the stress area, that is the tensile stress area, and the Young's modulus of the elasticity and the grip length in accordance with the established formulations within the IDEA Statica software.
Okay, thanks a lot, Kirti. Just one last question. In Idea Statica connection, why does the analysis sometimes not reach 100% load?
Uh, so there could be multiple reasons for your analysis is stop, before reaching out to 100%. So actually, we need to check the models what is causing the issue. But to give you the answer in short, there might be different reason. But one reason might be because the connection might limit its limit strength before your full load is applied. Like you can check all this in your code setup tab. So when the stop at the limit strength is setting is there, that is enabled, the software automatically stops the calculations when any part of your connections exceeds its allowable strain. I mean, for example, you might get messages like analysis is, for example, the 70% or the 60%, which represents the maximum load the connection can carry before the failure. The this is might be one reason, and other reason might be due to the convergence issue. In that case, you might increase the value of the number of the analysis iterations again from the port setting tab, and you can also control the settings related to the GMNIA. So yeah, that might be the few reasons. So if you want us to look at the specific model, you can send us your model. So we'll be happy to address your query.
Okay, thanks a lot, Kirti. Thanks a lot. That those were the most frequently asked questions that we generally get. Happy to see all your responses. So we can move ahead. And if you want to try to explore Idea Statica yourself, we encourage you to do try our free 14 days trial. It includes all the set of features and complete support from Acero. You can just simply write to us at acero@the rate solutions@acero.in, and we will help you get started. So about support and licensing at Acero and IDEA Statica, support is a priority for us. So you do get dedicated channels like phone support, email, and online help. Uh, we are most dedicated towards supporting you in real time. Uh, about the licensing, so the license you get is a cloud-based annual or perpetual license. So it does provide flexible licensing options. And about learning resources, we do consistent webinars, courses, tutorials, manuals, and knowledge bases so that you get updated and keep updated on everything and anything that is about all our offerings. Right? These are the current users and ever growing users of IDEA Statica. IDEA Statica is a very widely accepted software, and they it's because of its basically acceptability and ease of use. It's one of the highest growing softwares in our portfolio. And before we wrap up, we have two exciting sessions coming up. So Bluebeam, which is a PDF collaboration and documentation software, and Risa 3D, which is a advanced software for 3D analysis and design across composite structures like steel, concrete, timber, and many others. Both of these you can find in our next sessions, next webinars, which is in the month of May. If any of you want to contact us, want to visit us, here are our details. We can pause for 10-15 seconds. You can note these down and maybe connect us with your technical team so that they may reach out to us. And yeah, with that, finally, I would like to thank you all on behalf of Acero Consulting Engineers for joining us today. If any of you want a demo session or a custom code or want to discuss integration of these softwares with the current workflow, you can reach out to us directly. And thank you, Kirti. Thank you, Kirti, for the wonderful session today. And thank you all for joining us. See you all in the next webinar.
Thank you, everyone.
Thank you.